my dimensions PL mu is always equal to PR. So this has to be equal to this and this has to be minus equal to this. Then the only alternative left with us is both of them should be 0. So PL mu is 0, PR mu is 0. Finished. So if that happens, then this is also equal to plus of that, minus of that. Okay. So we are safe. All right. And another condition we get is k is an integer. Fine. That is also fine. So one conceptual outcome is that for open strings we can just survive by dealing with one kind of modes, because other one is just the minus of that. Okay. That too not always. Here it's just identically the same for Neumann boundary conditions. For Dirichlet boundary condition, this is equal to minus of that. So what we are going to do with these modes ultimately is to construct the mass spectrum of the theory. Okay, so if we know one, we also know the other. So it's enough to talk in terms of one of the modes. All right, the other mode is essentially the same. Okay, and if we consider the closed strings, then for closed strings also it follows that this holds true, but this does not hold. Okay, so for a closed string, this is right now. These are the results for the open string with Neumann boundary conditions, and these are the results of the and for the closed strings, P mu L is P mu R is fine, and alpha mu K is not equal to beta mu K, but K is still an integer. But K is still an integer. So no problem. When we talk about closed strings, we consider both the modes, alpha and beta, for everything. So like if you want to write down commutation relations, for them you write down for alphas as well as for betas. In open string, it's enough to write for one and the other one follows. Okay. Good. So this is what is the summary of all this. And yes, here let me explain this. Let me come back to these Fourier modes or these expansions, Fourier expansions of these things. Now we know that k is always going to be an integer. I must make a remark here that these three cases, open string with Neumann, Dirichlet, k is an integer. Closed string, it's an integer. But if you consider Neumann, Dirichlet, Neumann, k is not an integer. Okay, but I would not be considering these details, but it's very trivial. You apply those conditions at one end, at sigma equal to 0, you apply x dot equal to 0, for example. At the other end, you apply x prime equal to 0 and derive the consequences. You will find that this should be half integer. Okay, k should be half integer. It's enough to know, remind ourselves that okay, but otherwise this is going to be an integer. Okay, and when it is going to be an integer, k not equal to 0, so k we could replace maybe everywhere by, let us say now, n or m, just to remind ourselves that this we are dealing with an integer. Okay, but still n not equal to 0. So what happens here, n But otherwise n goes from minus infinity to plus infinity. So what does it mean? It means for my n, I would have minus infinity, minus 2, minus 1, minus 3, okay? And then plus 1, plus 2, plus 3, plus 3. Okay? So the sum goes from here to here, also from here to here. But here, at the moment, I am excluding the term n equals to 0. But I would include it shortly, and so at some places you can include it. So what actually happens, that n equal to 0 corresponds to the 0th order frequency mode, or in short, it's called a 0 mode. Okay, the 0 mode, which is the 0th order frequency mode. Okay, so for that, I would have let me not make mistakes. So I come back to my pages. So alpha 0 mu, this factor actually could also be written in terms of alpha prime. Okay, alpha prime, the Rajai slope, it's related to this string length. So this PL mu and beta 0 mu equal to LS by square root of 2 P mu R. Okay, so these are the two terms. So if I would like, at some places, I would include them also in this manner, or I keep them out. Okay, alpha 0 and beta 0, and for that reason I have written n not equal to 0. So n not equal to 0 term is not there, but otherwise you sum it from minus infinity to minus 1 and plus 1 to plus infinity. Okay, all right. So now we can think of a few more things on this, but before we do that, I come back to what we have. This, I think now more or less we can, if we like, we can remove these expressions, okay? Because we now know fairly well all these things, okay? Okay. So now, one thing, what we have studied in the past, in general, for the polygon xn, we have proved that T alpha beta is equal to 0, correct? In general, T alpha beta has to be 0. So what does it mean? All its components like T plus plus here or here, as you like, T plus plus, you can relate them, okay? You can take one sign up or down as you like with the help of that Lightfront metric. Okay, so T plus plus, T plus minus, T minus plus, T minus minus. Okay, that is my T alpha beta. Okay, in these two dimensional worksheet. And then we have also proved that this is 0 and this is 0, and this we have non-vanishing values for them. And what are they? Let me avoid making mistakes. So I write T plus plus is del plus x mu, maybe whole square, or del plus x mu, del plus x mu, and t minus minus is, so this is del minus x mu, and Matheus, I have just said that we have already proved that d alpha beta is 0, correct? In general, for the Polyakov action, and therefore all its components also have to vanish. And we have seen t plus minus is 0 and t minus plus is 0. So the point is, what is the physical spatial meaning or physical conceptual meaning of these objects called t plus plus and t minus minus? T plus plus, in my notations, I obtain as del plus x mu whole square, okay? And t minus minus, I obtain as del minus x mu whole square. So t plus plus vanishes on its own, t minus minus vanishes on its own. These are called as Virasoro constraints of the theory. And at the moment, they are at the classical level. When I am talking in terms of x mu, then they are the classical Virasoro constraints. Okay? Now, but I know my x mu, I can make a Fourier space decomposition for x mu. The Fourier, I can expand it in Fourier modes. Those Fourier modes, alpha mu k and beta mu k, or alpha mu n, beta mu n, they are quantum mechanical operators. They are the annihilation and creation operators. Okay? I mean, one and its del.